Alright guys, we are going to talk about volume now. So we did length and mass today in class, practice those, practice some unit conversions as well as the standard and scientific notation. So now we're going to move on to measuring volume. Most of this again should be a pretty big review for you. We know that volume is the amount of space that an object takes up, and we know that the base unit in the metric system is liter, and it is either represented by a big L or a little l. Doesn't matter. The metric units. So these are just some common conversions. We know 1 liter equals 1,000 milliliters, and with volume it's a little bit more confusing because there's two ways to take volume. We can take volume like we take volume in a math class where we measure the length, the width, and the height, and we find the volume of this cube or this long rectangular prism or a sphere or all of these different shapes we can find the volume of using math, using the length times width times height. So when we do that, we tend to get a measurement, okay, that is usually some sort of meter, either centimeters, decimeters, millimeters, cubed, because you're multiplying centimeters times centimeters times centimeters, right? 10 centimeters times 10 centimeters times 10 centimeters equals 1,000 centimeters cubed, or 1 cubic centimeter. That's what you see here, 1 cubic centimeter. In metric units, 1 cubic centimeter is actually completely equal to 1 milliliter. So we can interchange the mass that we take with a metric ruler or with a meter stick and interchange it with the volume that we can get through graduated cylinders. So really quick, let's do some conversion practice. So here's our thing. So if we're comparing 1 liter and 1,500 milliliters, which one is going to be larger? So again, we need to convert either the liter into milliliters or the milliliters into liters. So we'll do the milliliters into liters today. And so we know we're starting at milliliters. We're going to go 1 jump, 2 jumps, 3 jumps, because liter is a base unit. So we do 3 jumps to the left. So that means here we go 1 jump, 2 jump, 3 jumps, so that's going to be 1.5 liters. So which one is bigger, 1 liter or 1.5 liters? 1.5 would be, or 1,500 milliliters. So 200 milliliters or 1.2 liters. So 200 milliliters or 1.2 liters. Again, we're doing the base unit and milliliters, so you can take your pick which way you want to go. Since we went this way last time, we're going to go this way this time. That means we're going to change the liters into milliliters. So here's our liters. It's 1.2. Okay, and that means to get to milliliters, we need to go 1, 2, 3 bounces to the right. So that means this decimal point right here is going to move 1, 2, 3 bounces to the right, which means we're going to put 2 zeros in behind, okay, for those blank spaces. All right, and it's going to be 1,200 milliliters. So which one's bigger, 1,200 milliliters or 200 milliliters? It's going to be the 1,200 milliliters or 1.2 liters. Here, 12 centimeters cubed or 1.2 milliliters. Now, if we remember, guys, 1 milliliter and 1 cubic centimeter are the same. Okay, they are the exact same. So if I'm looking at 12 cubic centimeters, that means I'm also looking at 12 milliliters. So what is going to be bigger, 12 milliliters or 1.2 milliliters? It's going to be the 12 milliliters or 12 centimeters cubed. Measuring volume. So when we measure volume, oftentimes in science we are going to use these tools called graduated cylinders. They look like this. You'll get plenty of practice using them, so if you have not seen one in person, don't worry, you will. So when we're doing it, okay, we are going to read the measurement on the bottom of the meniscus. This curved line right here is called a meniscus, and when we read at the very bottom of it. Okay, so for this case, we would look at it and we'd say, okay, 40, that's the closest line underneath it, and then we're going to count up, so 41, 42, and the bottom of the meniscus looks like it's going to be right at 43. So the volume of the cylinder would be 43. So a lot of people ask me, well, what causes that meniscus? How come it bends down in the middle? And basically water, the molecules in water are attracted to the sides of the container. So you will usually get that little like bending of the liquid when it's in one of those, okay? So measuring volume. So if we're paying attention to the scales, okay, we want to make sure we know what each line means. All right, we're going to look here and we know that each line here is, so each of the big lines are 10, right? Because each of these big lines we count by 10, 10, 20, 30, 40, 50. So that means if there's 10 lines in between, which there is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that means that each line is going to be worth 1. Right? Because 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that means that when we count this, we can go to the number, the big line below the liquid, and now we can count to where the liquid goes to. So 50, 51, 52, because we know each of those little lines is 1. So this one would be 52. Here, notice that each line, we're now counting the big lines are by 5. So 5, 10, 15, 20. And there are how many lines in between the numbers? 1, 2, 3, 4, 5. Looks like there's 5. So technically each of these lines as well is only by 1. So that means we can go to the big number just below it, so we know 35, and we can count up because we know each little line is 1, so 35, and then 36, and then 37. So this would be 37 milliliters. And then finally, I'll move this up here. Okay, we know here we've got, look, oh, we only have one line in between each of these. Okay, so we need to figure out what do each of those lines mean. So between 5 and 10, there are 5 units, right? 10 minus 5 equals 5. But there's only one line in between, so it divides that 5 by 2, right? We said there are 5 units in between 5 and 10. Only one line, but you see 2 spaces. So that means that 5 divided by 2 is going to be 2.5. So each of these lines equals 2.5. So this would be 5, this would be 7.5, this would be 10, this would be 12.5, this would be 15, this would be 17.5, so and so on and so forth. So to measure this, we'd look at the largest line again. So this is 20. We know that this is 2.5, so 22.5, and it's just above that. So we would estimate in this case, and I would probably estimate that to be about 23. So measuring a solid, when we have a solid that is regular, meaning it has a length, a width, and a height that can easily be measured with a metric ruler, then we just measure it. So here we just go 10 times 8 times 9, 10 times 8 times 9, so that would be 720. So 720 cubic centimeters. Now, when we are measuring volume with something that isn't a cube or isn't something I can easily take a measurement with, okay, or a weirdly shaped thing, we use displacement. So first we look at a graduated cylinder like this. Okay, we look at the volume of water just in it. We put water in it. We look at the volume. So the volume in this one is probably about 200. Okay, so 200 is our volume before. Then we put our irregularly shaped object into here, and we look at how much the water goes up. So if this is 200 and this is 300, 1, 2, 3, 4, 5, that means there's 5 spaces in between it. Okay, so 100 divided by 5 is 20. That means each of these little lines, 1, 2, 3, 4, 5, equals 20. So 220, 240, 260, 280, 300. And I know I'm right because I can count it up. So now we're going to look at where the line ends. So here's the meniscus, the bottom line, and that falls right on this one. So we can say, all right, 220, 240, 260. So now the volume is 260. So we take the difference, okay, because the thing that made the volume in this one go up is putting the object in. So whatever it goes up is whatever volume is in this object. So since it went up to 260, we'd take 260, we'd subtract the 200 in just the water, and that would give us 60. So we know the volume of that irregularly shaped object is 60. So we're going to go ahead and look really quick at this in action. Okay, go ahead and close that because I already have it up. Okay, so we're going to look at this and we're going to say, okay, our volume before we start without anything in the graduated cylinder is 500 milliliters. All right, 500 milliliters. Now, if we put an object in it, there it is. It's a looks like a carrot, a very irregularly shaped object, and it goes up to 600. So we take the after volume, which is 600, we subtract our before volume, which is 500, and we get that that carrot, okay, has a volume of 100 centimeters cubed. Okay, now we'll try a different one. So our volume before anything's in there is 500 milliliters. Now we're going to go ahead and put an irregularly shaped object in, looks like an onion, and it goes up from 500 to 775. That means we subtract, so 775 minus our initial volume, 500, is going to give us 275 cubic centimeters. Okay, and we'll do one more. So we look at our volume beforehand, which is 500 again. We put in our irregularly shaped object, looks like a tomato now, and it goes up to 675. So we take the volume with the object in it, 675, we subtract the volume of the water without anything in it, so 675 minus 500, and that gives us 175.
Excellent.
Okay, so I hope that that made sense to you. Please let me know if you have any questions. Thanks.